A brand new average car in the United States right now costs right around $50,000, fully loaded, with a warranty, a dealer network in every town, and a manufacturer that builds millions of that same engine every single year. A single mid-size marine diesel, the kind that pushes a boat 35 to 45 feet long, can cost $20,000 to $40,000 for the bare engine alone, before installation, before the transmission, before a single wire gets run. And the moment you need two of them for a twin-engine boat, you are already well past what that $50,000 car cost you for a pair of engines that share the same basic architecture as the diesel already sitting under the hood of a heavy-duty pickup truck. Same basic idea: pistons, fuel, compression, an engine that turns diesel into motion. So why does the one that floats cost so much more than the one that drives? The answer is not a scam, and it is not greedy dealers marking up a commodity part. It comes down to 5 specific, provable differences between an engine built for a road and an engine built for the ocean, and once you actually see them laid out, the price tag stops looking absurd and starts looking like exactly what it is. Please subscribe if this video is helpful. The first reason is volume, and it is the single biggest one. A major automaker sells its most popular diesel engine hundreds of thousands of times a year, sometimes over 1 million, across trucks, SUVs, and cars that all share the same basic block, the same tooling, and the same supplier contracts for every piston, injector, and gasket that goes into it. Every dollar spent designing that engine, tooling the factory, and certifying it gets divided across an enormous number of units, which is exactly why a diesel pickup often costs only a few $1,000s more than the gas version, despite being a fundamentally different, more complex engine to build in the first place. A marine diesel manufacturer is selling into a market that is a rounding error by comparison, often a few thousand units a year across an entire model range, split further across dozens of horsepower ratings, built to power everything from a small sailboat to a 50-foot trawler. The United States government's own Federal Register has explicitly acknowledged this exact problem in marine engine rulemaking, stating plainly that low expected sales volumes make it harder for manufacturers to recover the investment needed to develop and certify new marine engines in the first place, to the point where regulators have had to build special provisions into the certification process just to keep manufacturers willing to bring new marine engines to market at all. Every research dollar, every tooling dollar, every testing dollar on a marine engine gets divided across a fraction of the buyers an automotive engine enjoys, and that math shows up directly on the price tag before a single unit ever reaches a dealer. The second reason is that a marine diesel is not just a truck engine with a new paint job, it is a substantially re-engineered machine, even when it starts life as the exact same block. Marine engineers who specialize in this exact conversion process describe a long list of systems that have to be rebuilt from scratch. The exhaust manifold, air-cooled and bolted to the outside of an engine bay on a truck, has to become a fully water-jacketed component on a boat, because an open flame-hot manifold inside an enclosed engine room is a fire risk a car never has to consider, and fabricating that manifold well enough to seal perfectly against the cylinder head without leaking water into the cylinders is genuinely difficult. Precision work that a cast component from the factory does far better than any aftermarket weld job ever will. A turbocharger that simply gets wrapped in heat shielding on a truck has to be water jacketed too, for the same reason, since insulation alone cannot survive the sustained heat inside a closed machinery space the way open engine bay airflow lets it survive on a highway. The fuel system needs a mechanically driven lift pump feeding through a water-separating pre-filter, because a car that loses fuel pressure coasts to a shoulder, while a boat that loses fuel pressure goes dead in the water, possibly into a channel or a reef, and a diesel that loses prime is not a quick restart, it has to be manually bled before it will run again. Even the throttle behaves differently. automotive injection is linked directly to the accelerator pedal, while marine engines need a governor system to keep from stalling the instant a boat suddenly shifts from forward momentum into reverse, a scenario that simply does not exist on a highway. Add in a completely separate transmission coupling, custom engine mounts tuned to the specific weight and vibration profile of that installation, and a raw water cooling circuit that has to be plumbed and pressure tested by hand, and none of that is optional equipment. It is the actual engineering cost of making a land engine survive at sea, and it is exactly why home-built conversions using a cheap second-hand truck engine so often end up costing more in the long run than simply buying the proper marine version to begin with. The third reason is duty cycle, and it is one most car owners never think about. A car engine spends the overwhelming majority of its life loafing, cruising at a fraction of its output, with brief bursts of real load during acceleration or a highway merge, then idling at a stoplight moments later. A marine diesel pushing a boat up onto plane, or holding a trawler at cruising speed for 6 straight hours crossing open water, is frequently running near its rated output the entire time it is running, with no stoplights, no coasting, and no downhill stretch to give the engine a break. Engineers who work on both platforms describe this as the core reason marine components have to be built heavier throughout. Larger cooling capacity to shed constant heat instead of intermittent heat, more robust internals to handle sustained load instead of occasional spikes, and injection pumps sized for hours of high output rather than a few seconds of merging onto a highway. An engine designed to loaf most of the time and work hard occasionally can be built lighter and cheaper than one designed to work at or near capacity for the entire time it is running, and that difference in expected working conditions changes nearly every component spec on the engine before it even reaches the water. If you've made it this far, the fourth reason is the one almost nobody outside the industry knows about. Marine engines answer to a completely separate set of federal regulations. On top of the standard highway emissions rules an automotive diesel already has to meet, marine diesels have to be separately certified against their own EPA marine emission tiers, and, depending on where they're sold, international maritime standards on top of that, each with its own dedicated testing cycle, its own durability demonstration, and its own certification paperwork layered directly on top of the low sales volumes from reason 1. A manufacturer has to fund an entire second compliance program, a second set of engineers, a second round of durability testing, specifically for engines that will sell in the thousands rather than the millions, and every dollar of that program gets baked into the price of every single unit sold, rather than spread across a mass market customer base, the way an automotive certification cost gets absorbed. Even the fuel itself gets tested differently, since marine certification cycles account for the wider range of fuel quality a boat might actually encounter at a random marina fuel dock compared to the far more consistent fuel supply chain a car pulls from at a regulated highway gas station. The fifth reason is consequence. When a car engine fails, you pull onto the shoulder and call for a tow. When a marine engine fails, you are adrift, possibly offshore, possibly in a shipping channel, with no shoulder to pull onto, and no guarantee help arrives before the current or the weather does. That single difference changes the entire engineering philosophy behind the product. Redundant cooling paths, sacrificial zinc anodes, bolted throughout the raw water circuit specifically to corrode in place of the actual engine components, corrosion-resistant alloys, like cupronickel used for tubing that never has to exist anywhere on a car, and sealed, epoxy-coated electrical components built to survive salt air and constant vibration instead of a dry garage. All of it exists because a failure at sea carries a fundamentally different risk profile than a failure on a road, and manufacturers price the engine accordingly, not because they can charge more, but because building an engine that fails safely at sea genuinely costs more to engineer than one that just has to fail safely onto a paved shoulder. Put those 5 reasons together, and the numbers actually make sense. That $50,000 car is built on a platform selling in the millions, certified once against a single set of well-amortized automotive standards, doing a job that rarely stresses it anywhere near its limit, backed by a tow truck, a phone call away, and a service department in every town in the country. That $20,000 to $40,000 bare marine engine is a fundamentally re-engineered machine built and certified for a market a fraction of that size, designed to run near its limit for hours at a time, held to a second, separate set of federal emissions standards on top of the automotive baseline, and built on the assumption that if it fails, nobody is coming to pull you off the highway. The same underlying logic even shows up inside the marine world itself. Manufacturers who build both gas and diesel marine engines consistently price the diesel higher, specifically because the higher fuel pressures and more robust components a diesel needs to survive under that sustained load cost more to build than the comparatively simple systems a gas engine gets away with. You are not paying more for the same thing with a boat logo stamped on the valve cover. You are paying for an entirely different design brief, built for an entirely different set of consequences, and the moment you actually understand what that brief requires, the price stops looking like a ripoff and starts looking like exactly what it costs to build an engine that has to survive the one environment cars were never designed for in the first place. If this video helped, hit subscribe and let us know if you'd still pay it. Stay smart on the water.